PSE meat, or pale, soft, exudative meat, is a carcass quality condition seen in pork, beef, and poultry. It has an abnormal color, consistency, and ability to hold water, making the meat dry and unattractive to consumers. PSE meat is the result of a rapid post-mortem pH drop along with the muscle temperature being too high. Low pH and high temperature have an adverse effect on muscle proteins, reducing their ability to hold water. The meat drips and becomes soft and mushy, and causing them to reflect light from the surface of the meat appears pale. To analyze the biochemical and physical properties occur in PSE meat. To investigate PSE meat condition at different time after slaughtering, we obtained the fresh sample from Kide Ayamprosa's Pak Long. The chicken carcass for the control sample was chilled immediately in an ice box after slaughtering. Firstly, we performed color determination by measuring the surface color of the control sample using a colorimeter. The right pectoralis was dried using a paper towel and the lightness, redness, and yellowness of the sample were recorded. The experiment proceeded with pH determination using a pH meter where we minced 2 g of sample right pectoralis and immersed it into distilled water with ratio sample to distilled water is 1:5. The pH meter was calibrated first using pH 7 buffer solution and the data obtained were recorded. Next, for water holding capacity, 3 g of sample right pectoralis was weighted and placed it in between Wutman paper number 1 and aluminium foil upside down, then pressed it with 2 kg load. The weight after being pressed was recorded to calculate the water holding capacity using the following formula. Then, shear force determination was carried out by using sample pectoralis that have been cut about 1 cm width times 1 cm thick times 3 cm length parallel to the myofiber. This process is used to determine tenderness sample pectoralis using Warner-Bratzler shear force. The sample has to shear perpendicular to muscle fiber orientation and the peak of shear force was recorded in Newton. All the steps were repeated to analyze PSE chickens after 60 minutes and 120 minutes. The readings were taken triplicate for each sample. Visual appearance. The results show that the PSE poultry meat is paler than controlled poultry meat. From the results show, pH for control was 6.45 while for PSE in 60 minutes and 120 minutes were 5.96 and 5.77. There is a significant difference in pH, P less than or equal to 0.05, between control and PSE poultry meat. The pH for PSE rate of acidification after slaughter was stimulated faster than normal and lower pH values are reached in the muscle when the meat temperature is still hot. Acidification occurs in muscles post-mortem because of glycogen breakdown to lactic acid. Besides, the combination of low pH and high temperature result in protein denaturation, water loss, and an open muscle structure. From the results show, L** color for control was 44.37 while for PSE in 60 minutes and 120 minutes were 46.91 and 50.06. The L** color indicates lightness where the PSE show a high L** color and poultry meat more in a pale color, and the changes in pH also affect how light is reflected and absorbed and thus affect the visual appearance. The low pH also promotes oxidation of oxy and deoxy-MB to brown MB, which combined with high light scattering from the meat surface, gives the meat its pale color. Light scattering from the surface of the meat is most likely caused by differences in the refractive indices of the myofibrils and sarcoplasmic. The higher the differences, the higher the scattering and the meat is paler. The amount of light reflected from the meat increases as the myofilament shrinks. The amount of absorbed light is low at high scattering, and the HEM pigments selectively absorb green light, reducing the normal red color. This makes PSE meat less red and more yellow. WHC is a fundamental meat factor of concern that can be used to assess PSE meat. The result proves that the percentage of water holding capacity has decreased from 97% to 93%. Between control and PSE poultry meat, there is no significant change in WHC, P 0.05. The decreased WHC value of PSE meat is related to its low pH and, more importantly, the denaturation of myofibrillar and sarcoplasmic proteins. Because PSE meat has a low WHC content, it has a soft, almost mushy texture. Several studies have found that PSE meat is less tender than normal meat. It was possible to conclude that PSE-like meat had lost its elasticity and had become hard gummy, making it difficult to chew in the mouth. PSE-like meat has a higher shear force because the hardness ranges from 2.30 to 5.32 N/mm section. The firmness of meat poultry increased between control conditions, followed by 60 minutes and 120 minutes periods of time, with low to high values ranging from 0.98 to 2.63. As a result, there is a significant difference in shear force value, P 0.05. So what we can conclude from this video, PSE meat is the combination of low pH and high temperature that adversely affects muscle proteins, reducing their ability to hold water. The meat drips and is soft and mushy, and causing them to reflect light from the surface of the meat appears pale. After analyzing the result, The pH for PSE shows rate of acidification after slaughter was stimulated faster than normal. The changes in pH also affect how light is reflected and absorbed and thus affect the visual appearance. So the changes of acidity of meat affect the color of the meat. In terms of water holding capacity, the decreased WHC value of PSE meat is related to its low pH and, more importantly, the denaturation of myofibrillar and sarcoplasmic proteins. The texture PSE meat has a low WHC content, it has a soft, almost mushy texture. So, PSE meat is less tender than normal meat. At the end of the video, PSE problems in meat also have the prevention method, which is electrical stimulation method. Electrical stimulation will improve the carcasses of meat, hence can preserve quality of meat instead of getting problems such as PSE of meat.